projects. In this video, we are going to explain about the project title, a hybrid convolutional neural network model for automatic diabetic retinopathy classification from fundus images. Introduction. Diabetic retinopathy is a complication of diabetes that affects the eyes, specifically the retina. High blood sugar levels associated with diabetes can damage the tiny blood vessels in the retina, leading to vision problems and potentially causing blindness if not managed properly. Traditional methods of detecting diabetic retinopathy involve manual examination of retinal images by trained clinicians. However, this process is time consuming and requires expertise, which can lead to delays in diagnosis and treatment. Additionally, it might be impractical in regions with limited access to specialized healthcare professionals. The condition progresses through stages. Non-proliferative diabetic retinopathy (NPDR) is an early stage characterized by swollen and leaking blood vessels in the retina. If left untreated, it can progress to proliferative diabetic retinopathy (PDR), an advanced stage where fragile new blood vessels grow in the retina. PDR poses a higher risk of severe vision loss and other complications. The proposed deep learning model aims to automate the detection process using neural networks like Inception V3 and ResNet50. These networks are adept at feature extraction from fundus images of the back of the eye, and classifying them into different stages of diabetic retinopathy. By leveraging these advanced neural networks, the model can potentially provide early and accurate classification of DR, diabetic retinopathy, improving upon the performance of existing detection techniques. This can lead to faster diagnosis, timely interventions, and better management of the condition, potentially reducing the risk of vision loss and blindness for patients with diabetes. Objective. This project focuses on designing a specialized neural network, a hybrid CNN, specifically tailored to automatically identify and classify diabetic retinopathy in fundus images. The emphasis on creating a model capable of precise and accurate diagnosis without human intervention. By leveraging ResNet50 and Inception V3, two advanced deep learning architectures renowned for their feature extraction capabilities, this model systematically captures and extracts intricate visual patterns and characteristics from fundus images. These extracted features are then concatenated before being inputted into the CNN for the final classification process. The model's effectiveness and accuracy are thoroughly assessed using a well-established dataset of fundus images. It undergoes rigorous testing and comparison against existing state-of-the-art methods in the field of diabetic retinopathy detection. Through this evaluation, the model's superiority and enhanced performance over other techniques become evident. The primary aim of this project is to create a robust tool capable of identifying diabetic retinopathy at its early stages. Early detection plays a pivotal role in preventing vision impairment caused by diabetes. By facilitating timely and proactive treatment, this model aims to mitigate the risk associated with diabetic vision loss and significantly improve patient outcomes. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are: application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. This stage involves importing essential libraries and frameworks like TensorFlow, Keras, NumPy, Pandas, and Matplotlib. TensorFlow and Keras are commonly used for building neural network models, while NumPy and Pandas aid in data manipulation and handling. Matplotlib is frequently used for data visualization, allowing exploration and visualization of images and model performance. Exploring the dataset, diabetic retinopathy classification. Loading the dataset involves accessing the repository containing fundus images annotated with diabetic retinopathy labels. Exploratory data analysis (EDA) involves understanding the dataset structure, examining its size, shape, and distribution of classes, different stages of retinopathy. Visualizing sample images help in understanding the nature of the data and potential challenges such as image quality or variations within classes. Image processing using image data generator, rescaling the image. Normalizing pixel values to a specific range, often between 0 and 1, ensures consistency and aids in faster convergence during model training. Shear transformation. This applies distortions to images along a specified axis, introducing variety to the dataset and helping the model generalize better. Zooming the image. Altering the scale of images by zooming in or out helps the model learn features at different scales, enhancing its ability to detect patterns. Horizontal flip. Flipping images horizontally introduces variations in orientation, further diversifying the dataset and improving the model's robustness. Reshaping the image. This step involves resizing or reshaping images to fit the model's input requirements, ensuring uniformity in input dimensions. Building the model. Defining the architecture involves specifying the layers of the neural network and their configurations. Configuring parameters such as activation functions, dropout rates, batch normalization, and optimizer setting. Model architecture design considerations include the number of layers, layer sizes, kernel sizes, and strides, which influence the model's ability to extract relevant features. Compilation involves specifying loss functions, evaluation metrics, and optimizer parameters. This phase sets up the neural network structure and prepares it for training with the pre-processed data from the dataset, aiming to achieve accurate classification of diabetic retinopathy stages from fundus images. Training the model. This phase involves feeding the pre-processed dataset into the hybrid convolutional neural network CNN model. The model learns from the data through an iterative process of forward and backward propagation, adjusting its weight and biases to minimize the defined loss function. During training, the model aims to optimize its parameters to accurately classify different stages of diabetic retinopathy using the labeled fundus images. Metrics such as accuracy, loss, precision, and recall are mentioned to evaluate the model's performance and guide adjustments in training strategies or model architecture. Flask framework with SQLite for sign up and sign in. Flask, a Python web framework, is used for building a web application that handles user authentication functionalities like sign up and sign in. SQLite, a lightweight relational database management system, is utilized to store user credentials securely. The Flask application provides endpoints or routes for user registration, login, and authentication, ensuring secure access to the system. User upload an image for analysis. Users interact with the web interface to upload fundus images for diabetic retinopathy analysis. This feature allows individuals to submit the images through a user-friendly interface for classification using the developed model. The given input is pre-processed. The uploaded image undergoes pre-processing steps similar to those performed during the training phase. This involves resizing, normalization, and other necessary transformation to prepare the image for input into the trained model. The trained model is used for predicting the result. The pre-processed image is passed through the trained hybrid CNN model for prediction. The model applies its learned features and weights to classify the given fundus image into specific stages of diabetic retinopathy. Final outcome is displayed through front end. The predicted result indicating the classification of diabetic retinopathy for the uploaded image is displayed on the front end of the web application. Users can view the outcome of the analysis, often accompanied by additional information or recommendations based on the predicted stage of retinopathy. Algorithms used. In this project, we have utilized the following algorithms. The first algorithm is ResNet50. ResNet residual network is a popular deep learning architecture known for its deep layered structure. ResNet50 specifically refers to a ResNet variant with 50 layers, utilizing residual blocks to address the vanishing gradient problem in very deep networks. It introduces skip connections, allowing the network to learn residual functions, enabling the training of deeper networks without encountering degradation issues. Inception V3. Inception V3 is a deep convolutional neural network architecture, part of the Inception family developed by Google. It's characterized by its inception modules that employ multiple convolutional layers of different sizes within the same layer, allowing the network to capture features at various scales. Inception V3 is designed to balance between depth and computational efficiency, enabling it to learn intricate patterns in images effectively. Inception V3 and ResNet 50 combination with CNN. The combination of Inception V3 and ResNet 50 involves leveraging the capabilities of both architectures in a unified manner. This fusion occurs at various stages. Feature extraction, using both networks to extract distinctive features from fundus images. These extracted features are concatenated or combined before being fed into a subsequent CNN layer for classification. Ensemble approach, employing both models individually and combining their predictions using techniques like averaging or voting to derive a final prediction. The aim is to harness the strengths of both architectures, enhancing the model's ability to extract meaningful features and improve the overall accuracy and robustness of diabetic retinopathy classification. As an extension, we applied other deep learning models to produce a more robust and accurate final prediction. Comparison graphs. Comparison graphs offer a visual breakdown of how models perform across essential evaluation metrics. Models are compared with the parameters accuracy, precision, recall, and FN score. This is the accuracy comparison graph. On the x-axis, we have accuracy score, and on the y-axis, we have algorithm name. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances, both true positives and true negatives, to the total number of instances. This is the precision comparison graph. On the x-axis, we have precision score, and on the y-axis, we have algorithm name. Precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions, true positives plus false positives. This is the recall comparison graph. On the x-axis, we have recall score, and on the y-axis, we have algorithm name. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances, true positives plus false negatives. This is the FN comparison graph. On the x-axis, we have FN score, and on the y-axis, we have algorithm name. FN score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. Execution. To execute this project, first we need to open the code folder which contains the project source code files. The code folder, this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing users' requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I am copying the path. Open the Anaconda prompt. Use the cd command. followed by a space, and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link. And paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to enter all these details to register, but I have already registered. So click on sign in. So here we need to enter the username and the password which we have created, and then click on sign in. We have logged in successfully. So here we need to upload the image, and after uploading the image, we will predict the diabetic retinopathy. Now click on choose file. So here I'm selecting the second image. Now click on open. Now click on upload button. So here, this is the uploaded image and this is the prediction. The patient is diagnosed with moderate DR, that is moderate diabetic retinopathy. It means progression with most significant changes like larger areas of bleeding and swelling in the retina. Now we will upload some more images. Go to home. Now click on choose file. So here I'm selecting the first image. Click on open. Now click on upload button. So here we can see we got the result. This is the uploaded image, and the patient is diagnosed with normal DR, that is normal diabetic retinopathy. It means absence of visible signs or retinal damage due to diabetes, indicating a healthy retina. Now we will upload one more image. Now click on try again. Click on choose file. So here I'm selecting the third image. Click on open. Click on upload button. So here, this is the uploaded image, and the patient is diagnosed with severe DR, that is severe diabetic retinopathy. It means progress stage with extensive damage, including widespread bleeding, retinal detachment, and increased risk of vision loss or blindness. Now we will upload one more image. Click on try again. Click on choose file. So here I'm selecting the fourth image. Click on open. Click on upload button. So here, this is the uploaded image, and the patient is diagnosed with proliferative DR. It means proliferative diabetic retinopathy, advanced stage involving the growth of abnormal new blood vessels, posing a higher risk of severe vision loss. Now we will upload one more image. So here I'm selecting the fifth image. Click on open, click on upload button. So here, this is the uploaded image, and the patient is diagnosed with mild diabetic retinopathy. Early stage characterized by the presence of microaneurysm and small retinal hemorrhages. In this way, by uploading the image, we can predict whether the patient is having diabetic retinopathy or not. And if the patient is having diabetic retinopathy, what stage it is, whether it is mild, moderate, normal, proliferative, or severe. Now click on sign out. The conclusion of the project is ResNet 50 and Inception V3 are two powerful deep learning models renowned for their feature extraction capabilities. By merging features extracted from both models, the hybrid model can capture a wider range of intricate and nuanced features present in diabetic retinopathy DI images. This amalgamation enhances the model's capacity to comprehend the complexities inherent in diabetic retinopathy images, potentially improving its accuracy in classification. Deep learning models like ResNet-50 and Inception V3 excel in automatically learning and extracting meaningful patterns and features from images. Leveraging these models specifically for feature extraction allows the proposed model to benefit from their ability to discern complex visual cues related to DR. This process enhances the model's accuracy and reliability in identifying distinct stages of DR from fundus images. The proposed model showcases superior performance compared to existing methods for DR detection. Its enhanced accuracy and effectiveness in early detection and classification of DR demonstrate advancements over previous models. This superiority signifies the model's potential to be a significant leap forward in the domain of diabetic retinopathy diagnosis. Diabetic retinopathy is increasingly becoming a leading cause of visual impairment among individuals with diabetes. The emphasis on early detection and timely treatment highlighted in the project underscores the critical need to prevent diabetic vision loss. By detecting DR at its initial stages, interventions can be applied promptly, mitigating the risk of severe vision impairment or blindness.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.